23, we're supposed to draw the picture and then state the reference angle. So we're supposed to draw a 500-degree angle on the coordinate plane. So where was 0 degrees at? Where do we start at? Where's 0 degrees? Yeah, over here. And then this was what? 90, 180, 270. Okay, and then once we get back to here, it's not only is it 0, it's also 360. And remember, like, not only is this 90, this is also, if you go around 1 1/4 times, it's 90 plus 360. 180 plus 360. And so on. Anyways, so how would we find where does 500 go? Well, the first 360 degrees gets you back to here, right? So how far past 360 is 500? 140. So you go this far and then you go to 140. Where's 140? Well, 180 is here. So 140 will be most of the way. So that is a 500-degree rotation. Goes around the whole loop and then a little bit more. You do have to draw the spiral to show that you're going around more than once, or you're going around. Anyways, the reference angle. Okay, I think the first time we did this, like 2 or 3 people got this wrong. The reference angle is how far is this angle from the x-axis, not the y-axis, the x-axis. So in other words, how many degrees are there between here and here? Well, remember I said we went 140 past this. So how far is 140 from 180? 40 degrees. 180 minus 140. So we also need to write somewhere 40 degrees. So this is the answer and the picture is also the answer. So there's kind of 2 parts to it. You don't have to draw the 90, 180, 270 stuff. You can, but there was a page on the book that was helpful with this. I don't know if I remember what page it was, but remember when we learned radians? What page was that? Page 453. Had a helpful picture. All right. Number 25. Use the unit circle to state the 3 basic trig ratios for each angle. Okay. Let's see. It says alpha equals 5 pi over 4. Let's, okay. We'll just use our calculator, I guess, on these. The problem is, I don't remember if I had you guys do this or not. I don't think I did. They're giving us these angles in radians. How can I tell? Because there's a pi right there. Usually we plug in like, what's sine of 60 degrees or something like that. What's sine of 54 degrees? If they say sine of 5 pi over 4, they're talking about radians, which means our calculators need to be in radians. Did we talk about, or was this the other class, changing the calculator to radians? This is the other class. Okay, so you hit second, like, or shift, or whatever your calculator says, and then on the Casios, I think everybody has a Casio, right? It's mode. So it's actually like we're doing the setup. So second mode, which is the setup. Everybody find it? And then I think does option 3 say like DEG?
Yeah.
So that means degrees, which the calculator is kind of automatically in. So we need to change it to radians. So what option is that? 4. So just hit option 4.
How do you change it back?
Yeah, well, go change it to degrees. Which we probably should do right after this so we don't forget. Because if later on, if you're trying to plug in the degrees, it'll screw up. You only have to do this when you're trying to plug in sine of the angle. That's the only time you really, or cosine or tangent, whatever. That's the only time you really need your calculator to be. Okay. And does everybody know where their pi button is?
Yes.
Hopefully you can find it. So let's try and plug in. What is sine of 5 pi over 4? Oh, I just thought of another way. Probably should have had you do it. What'd you get? Sorry. Negative square root 2 over 2. Okay. Actually, this probably would have been less explanation. Do you guys remember yesterday how we turned radians into degrees? I think it was 22. Yeah. How did we do that yesterday? Talked about turning radians into degrees. What's pi radians equal to?
Great question.
180. So yesterday I told you guys, if you're trying to change this to degrees, just turn the pi into 180. Okay, so we could have just left it in degrees and just turned the pi into 180. That probably would have been easier. We wouldn't have to mess with the calculator. Okay, 5 times 180 divided by 4 is like, I think it's 225, actually. So, yeah. Let's go ahead and change it all back to degrees. And we'll just, instead of 5 pi over 4, we'll just do 225. So what's cosine of 225? What's tangent of 225? Because I'm afraid we'll forget to change it back to degrees, and then you guys will get problems wrong if we have it in the wrong mode. Let's see, cosine, I believe, is also negative square root 2 over 2. And then tangent would be 1, I believe. All right, anybody plug that in? Yeah. Okay. Use the unit circle to evaluate. Do I care that much?
I don't.
No, probably not. I'll just let you guys do it. But how would we do, I'll just let you use your calculators. How would we do number 29? Secant of 270. Because secant's not a button on the calculator, so what would we plug in? 1 over cosine, right? Good. So on 29, you could just plug in 1 over cosine of 270. Cosecant would be 1 over sine. Okay, but what's different about 31, 32, 33, 34? They all have a pi in them, which means they're talking about radians. So you either need to change your calculator into radians or do what? Convert pi into 180 degrees. So on 31 it says cosecant of 13 pi over 4. So you can plug that in. If your calculator's in radians, you can just plug that in. Oh well, sorry, you'd have to do 1 over sine of 13 pi over 4. Or if you want to keep it in degrees, to change it to degrees, you swap out the pi with 180. So you could plug in this, 13 times 180 over 4. Any questions on that section? I know I didn't go through the others, so let you guys do it. Shouldn't take very long. Okay, then the graphs. So we're doing, let's see, what, 37, 38, and wait, no, 35, 36, 37, 38, and then 41 and 42. I guess there were 6 graphs. I was wrong. Not 4.
Actually, no. I lied.
Okay, 35, pretty basic. It's just y equals cosine of x. Okay, it wasn't too long since we did this. We did this right before break, like almost a whole week before break, I think. You guys remember, what does cosine look like? Where does it start at in the middle? Right, it starts at the top. Remember, sine and cosine look like waves, right? They're wave functions. And cosine starts at the top. And the top would be normally 1. And the bottom would be normally -1. And then remember how I had you guys like make 4 marks? We went backwards a little bit. So how far does cosine get before it starts repeating itself? Like how far is it from here to here? 2 pi, which is like 360 degrees. So you do need to label your graph. You can't just kind of randomly put marks. You have to say what's going on. So if you start at the top, the next step is down in the middle. The next step is the bottom, and back to the middle, and back to the top. Oh shoot, 30. I didn't even see that tangent right there. No, we never did tangent, and I don't want to do tangent. It's not. Yeah. Let's replace 36 with 40.
Go back up just a little. Hey.
We only did sine and cosine graphs.
Thank you. Thank you so much.
-3. I think I want to say 40 for last, actually. Let's work our way up to it. So we're on 37. It says g of x, but I'm still going to write y equals. All right. What does the 3 do to the graph? Right. It's called you guys remember what that was called? The amplitude. So instead of going up 1 like it did last time, it's going to go up to 3 and it's going to go down to -3. Okay, the period has not changed. I don't know if you guys recall, if there's a number in front of the x right here, that affects the period. So the period is still going to be 2 pi out here. Okay, where does sine normally start at here in the middle? Starts in the middle and it's going what direction? Up. So it goes middle, top, middle, bottom, middle, Okay, this one that does have a number in front of the x. Okay, so what does the 2 tell us about this graph? Right, it tells us to go up to, it tells us the amplitude. So the top of the graph is going to be at 2, the bottom of the graph is going to be at negative 2. Okay, what does the 4 do to the graph? Well, it makes everything go 4 times faster, so it's a horizontal compression. So normally where the period would be 2 pi, now the period is going to be a fourth of that. So you always do the period, normal period, 2 pi divided by whatever number is in front of the x. In this case, this would reduce to half a pi, pi over 2. So on my fourth mark, I'm just going to put pi over 2 because that's when it should start repeating itself. Okay, this is another sine function, so it should start in the middle, going up. So it's kind of like the last, it's kind of like 37. Since it's an even, I'll let you guys figure the dots out yourself. Okay, I'm going to replace 36 with 40. All right, what does a negative do to a graph? Yeah, upside down, right? And what is the amplitude of this graph going to be? 3. Not negative 3. A couple people, well, this might have been in the class. A couple people put negative on the amplitude. The amplitude is always positive. The amplitude goes both up and down, so there's no like negative amplitude. So anyway, the top of our graph is going to be at 3. The bottom of our graph is going to be at negative 3. But the negative is going to make the graph upside down. So cosine normally starts at the top. It's going to start at the bottom. Okay, what is the period going to be? Instead of the normal 2 pi period, it's going to be 2 pi divided by 1/2. If you divide by half, that's like multiplying by 2. You can plug it in your calculator, but it's just 4 pi. So each of these marks is like 1 pi. Okay, and it's a cosine, so you're starting, and it's a negative cosine, I should say, so you're starting at the bottom. Even Issa's not writing. Am I going that slow?
Well, because you didn't have the little dots on that one.
Yeah. I was letting you guys do it.
I don't know how I did it.
I'm proud of myself.
Yeah.
I'll figure it out when I get home. I'll ask my dad.
Bottom, middle, top, middle, bottom, middle, top, middle. Just alternates. Okay. Where are we? 41. I'm going to write this one down. So if I make it as messy as I can, it could look like this. I just made this one up, by the way. This is number 31, but this I just made up. So we have this number, and this number, and this number, and this number. Okay, we just talked about these two. What does this do to the graph? That's the amplitude. That tells you how high and low it goes. Up 2 and down 2 from the middle. What does the 3 do to the graph? Okay, it affects the period. Normally the period is 2 pi. In this problem it would be 2 pi divided by 3. Okay, now this we didn't talk about on the previous 4 because this is new. What is this minus 4 going to do to the graph? Moves it right 4. Yes, just like every other graph we've done, when you put a minus directly on the x, it affects the x motion and it does the opposite. So minus 4 moves the graph right 4. What does the plus do to the graph? Up 5, yes. Okay, so usually what I do is kind of start with these two. I move it right and up and then put a dot to like center. Where's this graph starting from? And then I use the amplitude to say, well, it's going up 2 and down 2 from there. And then if it's sine, it's going to go like this. If it's cosine, it's going to start at the top. Okay, so right 4, up 5. Or, of course, if you switch them around, this would be left 4, down 5. Okay, they didn't put any numbers in front, so the amplitude is still 1. They didn't put any number right there, so the period is still 2 pi. What is this going to do to the graph? Left pi. Yeah, usually these numbers are going to be like, our x-axis is degrees or radians, so they're usually going to be like degrees or radians. What's this do to the graph? Down 1. Okay, so to help me kind of center myself, I'm going to find where is left pi and down 1. All right. The period is still going to be 2 pi. Whoops. Okay. So I'm supposed to move my graph left pi. How far left would I have to go if I want to move pi left? Right. So if this is 2 pi, where is 1 pi at? Right here. So that means it takes 2 marks to go pi. This is like, pi is like 180, so this is kind of like pi over 2 or 90, this is pi or 180, 3 pi over 2 or 270, 2 pi or 360. So I need to move left 2 marks. So this, my graph is going to start right here, except for I need to move down 1. So this is not necessarily on my graph, but this is like the center of my graph. It's left pi, down 1. This is like negative pi over here. Okay, the amplitude, because there is no number out in front, is 1. That means the graph's going to go up 1 and down 1 from the center. So everything's going to happen between here. It's going to be like that. Okay, if it is a sine graph, where do we start? In the middle. So we are going to start at this point. If it was cosine, we'd start at the top. The top of my graph would be like the x-axis, and it would go down. But it's a sine, so sine's supposed to start in the middle, going up. And up, in this case, the top of the graph is up 1, so it's right there. Now that it's at the top, it's got nowhere to go but back down to the middle. So it's top, middle, bottom. Let's move that out of the way. Middle, top, middle, guess it did ask us to, in the directions, we kind of grabbed it all, but it did ask us to like list all the stuff we just talked about. So what is the amplitude on this problem? 1. Amplitude's the number in front, it's how much we went up and down from the middle, it's 1. What is the period on this problem?
1.
No. The period is how far it gets before it starts repeating itself. There, this had a normal period because there is no number in front of the x. So the period is the normal 2 pi. That's why I put 2 pi on the 4th mark. Okay, what was the next question? Oh, horizontal shift. They called it the phase shift. I don't really like that phrase, but how far did we shift horizontally? We moved left pi, right? So that would be a negative pi. The vertical shift, I think they called it K. I don't really care what you call it, but how far did we shift vertically? Down 1. So the vertical shift is negative 1. All right. So on 42, what is the amplitude? 2. Okay, how would you find the period on 42?
You put like 2 pi over that.
2 pi divided by
Pi over 2.
pi over 2. Okay, that will give you the period. That's how far it goes on the x-axis before it repeats itself. That's where the number I told you guys to put on the 4th mark is the period. Okay, what does the minus 1 do to the graph? Right 1. So that would be the horizontal shift, 1 to the right. What's the vertical shift? 0, because there is no number added outside of the parentheses to move it up or down. Okay, anyways. That is that.